Hi there everyone, this one is video number 63 and it is on inverse functions. Now, this topic follows on from the function stuff that we did in grade 2, right? And I made one of the questions in there slightly more complicated than the others, which was obviously the third one, which is always my hardest question. So it follows on nicely from that, but it gets an awfully lot more complicated, right? But the key words here in this one are inverse, and that means you are reversing something, so you're doing it in the opposite way. So the opposite thing to adding is subtracting. The inverse thing to adding is subtracting, so it's the same thing as that. And then key notation I've added in this video because it's important to understand the notation. If you can understand the notation, you can get your head around this topic a lot easier, right? Now this f of x here, I'm underlining, that just stands for the function of x. And basically what that means is it just replaces the letter y, alright? So y equals something, right? It's just f of x equals something instead, alright? And this f to the minus 1 of x is the inverse function of x, okay? So it's the opposite thing, going backwards. Now, understanding that, it's all well and good, but we need a method for when we're doing the inverse function. And in the first question, part A, we're not doing the inverse function. We're just doing some substitution, right? So I'll refer to the method in part B. Now, given that f of x is equal to 3x minus 2, and this is the function of x, 3x minus 2 is the function of x that we've been given, we need to find f of 3. Basically, that's just a case of substituting in. So f of 3 is equal to, now, instead of the x, we've got a 3. So instead of the x, we're going to put a 3. Remember, that means 3 times by 3. Minus 2, that gives us 9 minus 2, and 9 minus 2 is 7. So f of 3, it equals 7. Alright, relatively simple thing to do. Just understanding notation makes it easy, doesn't it? So, we're going to look at B and we're going to read the method now. So, find f to the minus 1 of x. Find the inverse function of x, that's what this is. And this is the method for that. So, change the f of x for a y. Fine, I will do that. The f of x in our original function turns into a y. 3x minus 2 stays as is. Swap the y's with any x's there may be in the function. So that x becomes a y, and that y becomes an x. So x equals 3y minus 2. Rearrange to make y the subject. So if you're rearranging, you're not sure how to do that, go and watch Changing the Subject to the Formula, and harder, Changing the Subject to the Formula, but not for this one, that's for question 3. Now, to do that, we just got to do x plus the 2 and then divide it by the 3. That would equal y. So there we go. We've got it. It's done. That is the inverse function. We've just got to then swap the y for f to the minus 1 of x. And there's our notation that's being used correctly. F to the minus 1 of x is equal to x plus 2 over 3. All done. Lovely. Okay. Yeah, it looks complicated, but follow those steps and you will always get it right. Okay, as long as you understand what you're allowed to do in the world of algebra. Okay, don't need to get rid of that because I'm moving on to question 2. Now, question 2, given that g of x, and this time we haven't got f of x, and it doesn't matter, it's actually just a different letter, and it means nothing different. It still can be replaced with a y. So g of x is equal to 4x minus 7 over 9. So let's do the first bit, which is find g of 5. Substitute a 5 in for where the x is, right? So g of 5 is equal to 4 times 5, which is 20, take away 7 over 9, right? And then the only thing we can do there is take away the 7 from the 20, which gives us 13 over 9, and then if we wanted to, we could turn it into a mixed number, and now it goes in once with 4 left over, 1 and 4 ninths, right? But g of 5 is equal to 13 over 9 will do me, okay? But it is good practice to turn your top-heavy fractions into mixed numbers, as I mentioned in the number section video on that. Now, question B. This is the inverse function bit. G, or the inverse function of g, so g to the minus 1 of 7. Oh, we haven't got an x in there this time. So we've got a number, so what we have to do is find the inverse function of g, and once we've found the inverse function of g, then we can put 7 into it, right? So I'm going to put, first of all, g of x, turn it into a y, equals 4x minus 7 over 9. Then I'm going to swap the x's and the y's. x equals 4y minus 7 over 9. Then I'm going to rearrange, so I'm going to get 9x equals 4y minus 7, get y on its own, remember, so take away the 7 and divide by 4, so 9x minus 7, oh sorry, add 7, because that is a minus 7 already. If I hadn't have looked up on the top one there, my working's a little bit small. So I'm going to add 7 to both sides, then I'm going to divide by 4. That leaves me with y. Okay, so what I then have to do is I have to change that y for the g to the minus 1 of x. So g to the minus 1 of x is equal to, that's an x there, is equal to this, 9x plus 7 all over 4. Alright, now simply, I say simply, it's not simple, right? All we now got to do is put 7 into this, because this is now our inverse function. We've just got to substitute the 7 in. So g to the minus 1 of 7 is going to be 9 multiplied by 7 plus 7 all divided by 4, right? Then do the calculation, so that's 63, and 63 plus 7 is 70. And then 70 divided by 4 is what the answer is. So 70 over 4, half and half again, or just think of it as a mixed number, or just give it as that. So I'm just going to put it as that, because I can't be faffed to work it out. Right, I'll leave you to do that if you so desire. I'd be happy with that as the answer on an exam paper. Unless it's specifically stated it's got to be a mixed number, or a decimal around a certain decimal place, or whatever. Alright, there you go. There is your answer. Exact answer. Right, moving on to the last question. This one is difficult, really, really difficult. Probably the hardest you'd get on this. Like, it's not a grade 6 question, more like a grade 8 question, I would say. If you're understanding this, you're probably on track for grade 8 or 9. So the function is such that hx is equal to 2x minus 3 over 5x plus 5. Find h to the minus 1 of minus 2. So not only do we have a harder thing here, a function here, let's not call it a thing, let's call it a function. We've got a harder function, we've also got a negative number to substitute in once we've got the inverse function of h. And again, it's just a different letter, it doesn't matter, it makes no difference. So we're going to change that for, and I'm probably going to have to use this entire space to do all this whole question. So y is what we're going to change the h of x to. Y is equal to 2x minus 3 over 5x plus 5, right? Then I'm going to swap the x's and the y's. But there's an x there and an x there, and they're both going to become a y. So x equals 2y minus 3 over 5y plus 5. Right, now, the only thing I can do here is multiply by this whole term. Make it a term by putting it in brackets, multiply by 5y plus 5 on both sides. That leaves me with x multiplied by 5y plus 5 is equal to 2y minus 3. Oops, don't need a bracket there, because there wasn't any brackets on it. Now, let's multiply out our bracket. So, that is 5xy plus 5x. That equals 2y minus 3. Let's get y all on the same side. That's the last thing I'm going to fit in down here. So 5xy minus that 2y is equal to, now it's not on that side, we need to get rid of that 5x on this side. There's going to be minus 5x minus that 3. Okay, now I'm going to go up here with my workings, because I've got no more room below. Basically, what we're going to do is we're going to factorize this side to get y on its own. So the only thing we can take out is y, right? And then 5x goes in the bracket, and then a minus 2. And that equals minus 5x minus 3. We could factorize this if we wanted to tidy it up, which I might do in the next step. Now, y is now going to be on its own. So y equals, and I'll factorize this, just take the negative out, 5x plus 3, all divided, so put brackets in, factorized it basically, all divided by 5x minus 2. Okay, and then we just change that y for h to the minus 1 of x. So h to the minus 1 of x is equal to all of this. Minus 5, x minus 3, sorry, plus 3, all over 5x minus 2. Told you it was a long-winded one. Right, A lot of concentration needed here, but I'm there. I've got it. I've got the inverse function. All I've got to do is substitute the negative number into it and then evaluate it. So h to the minus 1 of minus 2 is equal to, then we've got the negative in there. We've got 5 multiplied by minus 2 plus 3. And then we've got all over 5 multiplied by minus 2 minus another 2. So that's going to be minus 10 plus 3. Minus 10 plus 3 is minus 7. And then it becomes a plus 7. So that's because it's a negative on the outside. So a negative multiplied by the negative would give you a positive on the top. So we've got 7 on the top. And then we've got the minus 2 there. So that's negative 10, negative 12. So we've got minus 12. And then that's what pops out there. Okay, so the answer to that, h to the minus 1 of negative 2 is equal to negative 7 over 12. Okay, I don't know if the microphone's picking up the squeakiness of my pen. I've just made it go really squeaky by doing all that because there's so much to do there. It is a crazy question. I hope you enjoyed watching how to do that one. I'm sure you did. Please do click the link and have a go yourself. It's in the description section of the video. Please do not fear these questions because it is just stuff that you've learned prior, all pieced together. That's what a lot of higher level maths is, especially in the algebra section. So yeah, do your best and keep being lovely to one another. Like, subscribe, share everything that you're doing with loads of people, and then loads of people can benefit from understanding maths at this sort of level. All right, have a lovely day, take care of yourselves, and I'll see you in the next one.